What if, one morning, the sun simply vanished from the sky, not forever, but just for a single day? Could life on Earth survive even that brief silence? Chapter 1: The Calm Before the Storm. Imagine an ordinary morning on Earth. The sun rises over the horizon, painting the sky with warm light. Birds sing, people head to work, and satellites orbit quietly above us. It feels normal, safe, and familiar. The sun has always been there, steady and reliable, like a guardian watching over our planet. For billions of years, it has been the heartbeat of our world. Without it, there would be no oceans, no forests, no cities, no life at all. But what if this sense of safety is an illusion? What if, hidden behind the bright face of the sun, forces are gathering, forces strong enough to shatter our fragile sense of stability in a single day? Inside the sun, deep beneath its glowing surface, something incredible is always happening. Vast magnetic fields twist and coil, stretching like invisible ropes of energy. These fields grow tighter and more tangled over time, storing power in ways we can barely comprehend. For the most part, they remain contained, but sometimes the tension becomes too much, and all that energy erupts outward in a violent release. This is what scientists call a solar flare. At first, the word flare may sound harmless, like a spark or a burst of light, but a solar flare is not a simple flicker. It is one of the most powerful natural events in the universe. In just a few minutes, a flare can release more energy than billions of nuclear bombs exploding at once. When it happens, waves of radiation rush across space at the speed of light, reaching Earth in only 8 minutes. Most of the time, these flares are small. We barely notice them. They may disrupt a few radio signals or disturb satellite communications, but life continues without major problems. Yet history reminds us that not every flare is gentle. There have been storms strong enough to knock out entire systems, even in times when humanity relied on far less technology than we do today. The most famous case is known as the Carrington event of 1859. Back then, long before smartphones or satellites, people relied on the telegraph for communication. One night, operators across the world were shocked as their equipment sparked, caught fire, and even continued sending signals after being disconnected. The auroras, usually seen near the poles, stretched all the way to the Caribbean. For those who witnessed it, it felt as if the sky itself was breaking apart. And that was with technology far simpler than ours. Now imagine the same kind of storm striking in our modern age. We live in a world completely dependent on fragile electronic satellites, GPS, airplanes, power grids, internet cables. One strong flare could turn all of it against us. Planes could lose navigation mid-flight. Power grids could collapse across continents. Entire nations could fall into darkness, not just for hours but for weeks or even months. And this is where the real fear begins. What if such a flare was so massive that it didn't just cause blackouts, but made the sun itself seem to vanish? Not because the sun truly stopped shining, it cannot simply switch off, but because the sheer power of radiation distorted our skies, scattering light and creating the illusion that our star was gone. Imagine looking up and seeing only a faint, distorted glow where the sun should be. Humanity's oldest companion, the very source of life, hidden behind a wall of chaos. The thought is terrifying because we are not prepared. We rely on the sun every single day without question. It rises, it sets, and we live our lives assuming it will always be there. But beneath that steady rhythm lies a hidden truth. The sun is alive with storms, and those storms can touch us at any time. Scientists today work hard to monitor the sun's activity. With advanced satellites and telescopes, we can watch as magnetic fields twist and dark sunspots form on the surface. These are warning signs, clues that a flare might be coming. But even with all our technology, we cannot stop it. We can only observe, predict, and prepare as best we can. Think about that for a moment. For all our progress, for all our machines and inventions, we are still at the mercy of a star 93 million miles away. Its storms do not ask permission. They do not care about our cities, our technology, or our survival. They erupt when they must, and when they do, Earth can only endure the consequences. This brings us back to the quiet morning we imagined at the start. The calm sunrise, the normal day, the sense of safety. Beneath that calm, A storm may already be brewing. Energy may already be building inside the sun, twisting, tightening, preparing for release. And when it finally bursts, it will not arrive slowly. It will come at the speed of light. We will not see it coming until it is already here. That is the unsettling truth about solar flares. They remind us that our world, for all its order and structure, rests on the edge of something far larger and more powerful than ourselves. The sun gives us life, but it also holds the power to shake that life apart, and perhaps, one day, to make us question whether our most constant star could ever truly disappear even for a single day. So the stage is set. The calm before the storm is fragile, deceptive, and temporary. In the next chapter, we will witness what happens when the sun finally erupts, and Earth is plunged into the nightmare of a flare unlike any we have ever seen. Chapter 2. The flare erupts. The storm begins without warning. For weeks, scientists had observed dark spots forming on the sun's surface, twisting like scars across its glowing face. Magnetic fields tangled and tightened, storing unimaginable power. And then without a sound, without a hint that we could see from Earth, the sun released it all. A solar flare erupts. From the surface of our star, a blinding flash bursts outward. In less than a second, more energy is unleashed than all the power humanity has ever generated. Gamma rays, X-rays, and streams of charged particles shoot into space at incredible speed. There is nothing on Earth that can match this scale. It is as if a cosmic cannon has fired directly toward us. 8 minutes later, the storm arrives. At first, it seems like nothing has changed. The morning sky is bright, clouds drift lazily, and the sun still hangs above us. But then, strange things begin to happen. Satellite operators notice malfunctions. Signals cut in and out. Air traffic controllers lose contact with planes mid-flight. In the oceans, ships depending on GPS suddenly drift blind, unable to tell where they are. Within moments, the flare's true power becomes clear. A wave of radiation crashes into our atmosphere, disrupting the delicate balance that protects us from the harshness of space. Normally, Earth's magnetic shield, the magnetosphere, deflects most of the sun's fury. But this storm is different. It is far stronger than anything modern civilization has ever faced. The shield bends under the pressure, cracks of energy ripple through it, and radiation floods in. From the ground, people begin to notice strange sights. The skies glow with brilliant colors as auroras appear, not just near the poles, but across the entire planet. In places like New York, Paris, and Tokyo, the night sky blazes with green and red curtains of light. It is beautiful, but terrifying, because beauty is not the only thing this storm brings. Power grids across continents begin to fail. Transformers spark and burn. Entire cities fall into darkness as systems collapse under the sudden surge. Hospitals lose power, relying only on backup generators. Water treatment plants grind to a halt. Elevators stop between floors. Trains stall on tracks. Life that once felt secure and unshakable suddenly becomes fragile. Above the Earth, satellites are struck by the storm. Some are fried instantly, circuits destroyed by radiation. Others spin out of control, their signals corrupted beyond repair. Communication breaks down across the globe. Television broadcasts vanish. Internet services crash. GPS signals, the invisible web that guides planes, ships, and even our cars, dissolve into static. Humanity finds itself blind in an age where information is survival. The skies themselves seem to shift. The sun, usually so steady, appears distorted. To the naked eye, it looks dimmer, as if hidden behind a veil of chaos. Radiation and atmospheric interference create the illusion of a sun flickering, disappearing in waves. For the first time in history, billions of people look up and wonder, is the sun gone? Panic spreads faster than the storm itself. News outlets scramble to report, but with satellites offline and networks collapsing, the flow of information is chaotic. Some governments declare states of emergency. Others remain silent, unable to reach their people. Rumors swirl that the sun has exploded, that Earth is falling into darkness, that the end has come. For scientists who understand what is happening, the truth is not much more comforting. A solar flare this size is unlike anything we have recorded. The Carrington event of 1859 was devastating for its time, but today's world is far more vulnerable. Our entire civilization runs on delicate threads of electricity, on networks so complex that a single break can ripple into disaster. Now, millions of breaks are happening all at once. Air travel halts, pilots cannot trust their instruments, and many are forced to make emergency landings with no guidance. In space, astronauts aboard the International Space Station retreat, 2 shielded modules, hoping to survive the radiation storm. Meanwhile, ordinary people on Earth watch as their devices fail, their cities darken, and the familiar rhythm of life disappears in a single day. And still, the storm rages on. The first wave of radiation is only the beginning. Hours later, a second threat arrives, a coronal mass ejection, or CME, unlike the flare, which sends radiation at the speed of light. ACME is a massive bubble of charged particles, slower, but far more destructive. It barrels through space, slamming into Earth's magnetic field like a hammer. When the CME strikes, the chaos multiplies. The auroras intensify, lighting the sky so brightly they can be seen at noon. The magnetic surge overloads even more systems, destroying transformers and plunging entire regions into silence. In some places, power will not return for weeks. In others, it may be months. The consequences ripple across every part of human life. With satellites down, weather forecasting collapses, farmers cannot plan for storms. Cargo ships lose navigation, throwing global trade into chaos. Financial systems, dependent on precise timing signals from satellites, suffer massive disruptions. Transactions freeze, markets crash. For ordinary families, the change is immediate and personal. No lights, no internet, no phone service, refrigerators warm, food spoils, and water pumps fail. Cities that once thrived on technology turn into fragile shells, vulnerable and unprepared. Humanity has never faced a day like this, not in modern times, and yet, in the middle of the fear and confusion, there is silence. The sun, the one constant in human history, appears to falter. People stare at the sky, whispering questions that feel impossible to answer. Is this the end of the world? Is our star dying? Will it ever shine again? The truth is more complicated. The sun is not dying. It is not going dark. But the storm is so powerful that it warps our perception, creates illusions, and blinds our instruments. For a moment, it feels as if we are cut off from our star, abandoned in the cold. That feeling alone is enough to terrify billions. This is the reality of a flare unlike any in recorded history. A storm so vast, it makes the sun itself seem to vanish. A storm that plunges Earth into fear, chaos, and darkness, not because our star is gone, but because its fury is too much for us to endure. The eruption has begun, and the world will never forget it. But the question remains, what happens next? If the sun can vanish for a day, what becomes of the Earth during those long, silent hours? That is the story we turn to now. Chapter 3. A day without the sun. The flare has erupted. The shock has spread across the world. Now comes the silence, the long, unnerving moment when the sun, the one thing we believed could never fail, seems to vanish from our lives. Imagine waking up and stepping outside. The sky looks wrong. The light is pale and uneven, filtered through waves of radiation. The sun is no longer a bright, steady circle, but a flickering, distorted glow hidden behind a storm of particles. To the human eye, it feels as though our star has disappeared. This illusion is powerful. For billions of years, humans have trusted the sun to rise every morning. It has been the rhythm of time itself, the divider of day and night, the provider of warmth and energy. Now, that rhythm is broken. A single day without the sun shakes the very foundation of human belief. At first, the change is confusing. People stumble through the dim light, unsure of what is happening. Rumors spread quickly. The sun has gone out. The end has come. Fear takes hold in every corner of the globe. With communication systems down, there is no clear answer, no single voice of authority to guide billions of frightened people. As the hours pass, the consequences grow. Temperatures begin to drop, slowly at first. The oceans, vast and deep, hold heat for a time, buffering the worst effects. But on land, the chill becomes noticeable. Cities grow colder. Without power, heaters and electric systems fail. Families huddle together in the dark, wrapped in blankets, waiting for news that never comes. The night is even stranger. Normally, the stars shine in the absence of the sun, a quiet reminder of the universe beyond. But now, with Earth's atmosphere disturbed by radiation, the sky glows with auroras. Rivers of green, red, and purple light danced across the heavens, reaching far beyond the polar regions. People in Africa, South America, and Asia see auroras for the first time, painting the darkness with unnatural color. Beautiful, yes, but terrifying when no one knows if the sun will ever return. Psychologically, the effect is profound. Humanity has always looked to the sun as a symbol of certainty. Ancient civilizations worshipped it as a god. Farmers counted on it for crops. Scientists built entire systems of measurement around it. To lose sight of the sun, even for a day, feels like losing the anchor of reality itself. Panic deepens. In major cities, shops are raided for supplies. Without power, banks cannot operate, leaving people desperate for cash or trade. Gas stations close. Water stops flowing in many places as pumps shut down. The world begins to fracture into small islands of survival. Each family, each community fending for itself. For travelers, the situation is even worse. Airplanes grounded during the flare remain stranded, leaving passengers trapped in airports with no clear updates. Ships at sea, cut off from navigation, drift with uncertainty. Drivers on highways abandon cars when fuel runs out. The normal flow of movement that connects our modern world grinds to a halt. And yet, beneath the fear, the world is not truly ending. The sun continues to burn as it always has. Deep in its core, fusion reactions still rage, producing light and heat in steady rhythm. What has changed is not the sun itself, but our fragile connection to it. The storm has blinded us, clouded our atmosphere, and created the terrifying illusion of disappearance. Scientists know this, but with communication crippled, their voices cannot reach most of the population. The few messages that do get through are scattered and unclear. Governments try to reassure people that the sun is not gone, but with cities in darkness and screens blank, trust erodes. For many, the illusion feels more real than the truth. As the day continues, the world adjusts in small, desperate ways. Candles and flashlights become treasures. Families cook with whatever food remains before it spoils, without refrigeration. Some communities gather in public spaces, sharing resources and offering comfort in the face of the unknown. Others descend into chaos, driven by fear and mistrust. Animals, too, are affected. Birds, confused by the strange light patterns, fly in circles or crash into buildings. Livestock grow restless, unable to follow their natural rhythms. Even plants begin to close, tricked by the absence of steady sunlight. Life itself feels disoriented, shaken by a disruption it cannot understand. But perhaps the greatest impact is on the human mind. A day without the sun is more than just darkness, it is doubt. If the most reliable force in the universe can vanish, what else can fail? People whisper of doomsday prophecies, of the end of time. Religious groups declare judgment has come. Others retreat into silence, staring at the strange skies with hollow eyes. And still, the hours tick by. Slowly, almost painfully, the truth begins to show itself. The sun does not remain hidden forever. The storm begins to weaken. Radiation levels fall. The distorted glow sharpens, and light starts to pierce through the chaos. Humanity realizes, step by step, that the sun has not abandoned us. It was always there, waiting behind the storm. Relief sweeps across the world, but it is not the kind of relief that erases fear. Instead, it is mixed with awe and humility. For one long day, humanity faced the possibility of losing the very source of its existence. And in that silence, in that cold and terrifying absence, we were reminded of how small and fragile we are. The sun returns, but nothing feels the same. The illusion of safety is broken. We now know that the sun, while steady and life-giving, also has the power to shake our civilization to its core. It can hide, not by choice, but by the violent storms that rage within it. And if it can vanish for one day, who is to say it cannot vanish again? This is the paradox of our star. It is both our greatest protector and our greatest threat. The same energy that nurtures life can also unleash destruction. And though the sun shines again, humanity carries the memory of its absence the longest day, the day without the sun. But the story is not finished. We still must ask, why does the sun behave this way? What is happening inside our star that allows such storms to erupt? How can something so distant and so massive affect our fragile world so completely? The answers lie in the science behind the apocalypse. And to understand them, we must look deeper into the sun itself, into its cycles, its magnetic fields, and the unstoppable physics that drive its eternal fire. That is where we turn next. Chapter 4. Science behind the apocalypse. To understand how one solar storm could bring our world to its knees, we need to look closely at the science behind it. The sun is not just a glowing ball in the sky. It is a living, breathing machine of unimaginable energy. Its heartbeat is nuclear fire. Its breath is radiation. And sometimes, it sneezes with explosive force, casting fragments of itself across the solar system. When people imagine the sun, they often see it as constant and calm. But in reality, the sun is restless. Its surface is a battlefield of magnetic fields twisting, colliding, and snapping. This invisible struggle builds tension until something must give. When that tension releases, we see what scientists call a solar flare, a sudden, violent burst of light and energy that can be brighter than a billion nuclear bombs. Solar flares happen in the sun's outer layers, where tangled magnetic fields trap hot plasma. Think of it like stretching a rubber band too far. Eventually, it snaps. When solar magnetic lines break and reconnect, they hurl radiation outward at near light speed. These flares can reach Earth in just 8 minutes, flooding our planet with X-rays and ultraviolet radiation. But flares are only part of the story. The true monster is something bigger, a coronal mass ejection, or CME. Unlike a flare, which is mostly radiation, ACME is matter itself. Billions of tons of charged particles ripped from the sun's atmosphere and launched into space. Imagine the sun tearing off a piece of its skin and flinging it across millions of kilometers. That is what ACME is. When a CME is aimed directly at Earth, it doesn't just wash over us harmlessly. It slams into our magnetic field like a cosmic hammer. Earth's magnetosphere, usually a protective shield, bends and cracks under the impact. Charged particles rush in, sparking auroras and wreaking havoc on satellites, power grids, and communication networks. This is not science fiction. It has happened before, most famously in 1859, during the Carrington event, when telegraph wires burst into flames. Today, with our dependence on electronics, the damage would be far greater. But why does this happen at certain times? Why does the sun sometimes seem calm for years, only to erupt in fury? The answer lies in the sun's natural rhythm, its 11-year solar cycle. Every 11 years, the sun flips its magnetic field. The north becomes south, and the south becomes north. This reversal is not smooth. It's chaotic. Magnetic activity increases, sunspots multiply, and the chances of solar storms skyrocket. At the peak of this cycle, called solar maximum, the sun is at its most dangerous. Gigantic sunspots, some larger than Earth itself, appear on the surface, each one a potential source of flares and CME. At solar minimum, activity fades, but it never disappears entirely. The sun is always alive, always unpredictable. This is why solar scientists spend so much effort monitoring our star. Organizations like NASA and the European Space Agency (ESA) operate fleets of satellites. SOHO, Stereo, the Solar Dynamics Observatory, constantly watching the sun. These spacecraft give us early warnings when a flare or CME erupts. But here's the frightening truth. Early warning does not mean prevention. Unlike a hurricane, which we can evacuate from, or an asteroid, which we might one day deflect, we cannot stop a solar storm. There is no shield, no weapon, no switch we can flip to turn away the sun's wrath. The best we can do is brace for impact. Power companies can shut down transformers to reduce damage. Satellites can be put into safe mode. Astronauts on the International Space Station can retreat into shielded compartments. But for billions of ordinary people on Earth, the only option is endurance. And when such a storm is strong enough, endurance may not be enough. It's important to clarify something here. During a solar storm, the sun itself does not vanish. It does not burn out. It does not collapse into darkness. What people see, this strange dimming, the broken light, the eerie skies, is the effect of atmospheric scattering, radiation interference, and magnetic chaos. When solar particles flood our atmosphere, they excite molecules in the air, producing auroras and haze. Radiation disrupts the way light travels, bending and distorting the sun's rays. Magnetic storms twist the ionosphere, the layer of charged particles above us, scrambling radio signals and GPS. To the human eye, it looks as though the sun has flickered or gone dark, but the truth is more subtle. The sun is still shining, but the pathway between it and us has been disturbed. Think of it like listening to a radio through heavy static. The station is still broadcasting, but interference drowns out the signal. In the same way, the sun still burns, but solar storms fill our skies with static, so overwhelming that daylight itself feels broken. This distinction matters because it reveals the real danger. The sun will not simply wink out one day. That is not how stars die. But it can blind us, silence us, and cripple our technology, all without ever stopping its eternal fire. Humanity's dependence on electronics, satellites, and global communication makes us uniquely vulnerable to these disruptions. What would have been a dazzling light show for ancient farmers is, for us, a potential civilization-level disaster. This is why the science of space weather forecasting has become so urgent. Just as we track hurricanes and earthquakes, we now track solar storms. Yet space weather is still in its infancy. Scientists can predict when the sun is more active, but they cannot yet say with certainty whether a given flare will hit Earth, or how powerful it will be when it arrives. The time between detection and impact is often less than 24 hours. That is not much time to prepare a planet. Some researchers dream of building shields, giant magnetic barriers placed between Earth and the sun to deflect storms. But such ideas remain in the realm of science fiction. For now, humanity's defense is knowledge, monitoring, and preparation. And even then, a storm on the scale of the Carrington event, or greater, could overwhelm every safeguard we have. This is the unsettling truth. The sun, the very heart of life on Earth, is also a force we cannot control. It feeds us, warms us, lights our days, and makes our existence possible. But it also harbors storms of unimaginable power. And when those storms align with Earth, the result is chaos and global, and unavoidable. The apocalypse, if it comes from the sun, will not be fire raining from the sky, or the star going dark forever. It will be silence. The silence of dead satellites, the silence of powerless cities, the silence of a world cut off from itself. The sun is not our enemy. But it is not our servant either. It is a star wild, ancient, and indifferent. For all our technology, for all our mastery of Earth, we remain at its mercy. And that is the warning we must carry. The sun gives us life, but it also holds the power to unmake the world we know in a single day. Chapter 5. Humanity after the flare. When the flare is finally over, when the light of the sun seems calm again and the skies return to their ordinary blue, humanity would stand in silence, staring at a world forever changed. The most frightening part is not the flare itself, but what comes after. Because survival does not end when the storm passes. It begins. The first hours, silence across the world. Imagine waking up and every screen in your house is black. Your phone won't turn on. The TV is dead. The internet has vanished. Radio stations broadcast only static. Airplanes are grounded because navigation systems no longer work. And satellites, the very eyes and ears of our planet, are gone. The first hours would be chaos cloaked in silence. No GPS, no online banking, no emails. Governments would struggle to send emergency messages through outdated channels. Millions would not know if their families in distant cities were safe. That silence alone could trigger panic. The power grids struggle. Electrical grids are fragile, built on delicate transformers that cannot withstand massive surges of solar energy. A major flare would burn them out like matches. Repairing a transformer is not as simple as changing a fuse. They are gigantic machines that take months, sometimes years. to build and replace. Entire countries could sit in darkness for weeks. Hospitals would run on limited backup generators. Water systems that rely on electric pumps could fail, leaving cities without clean drinking water. Food distribution networks, powered by logistics software and refrigerated trucks, would grind to a halt. The modern world would feel medieval again. Economic collapse, the cost would not just be measured in lives, but in money. Trillions of dollars in satellites, communication infrastructure, and electronics would be lost in a single day. The stock market would collapse because financial systems depend on digital networks. Insurance companies could not cover the damage. Banks would freeze without electronic transfers. Global trade would stall as cargo ships and airplanes lose navigation systems. Within days, grocery store shelves would empty. Within weeks, industries would shut down. What took centuries to build the world's economy could unravel in a matter of months. Slow rebuilding, yet humanity is stubborn. We rebuild. Teams of engineers would work around the clock to restore power grids. Satellite companies would launch replacements, though it might take years to restore full coverage. The internet, piece by piece, would come alive again, but the scars would remain. Some businesses would never recover. Some nations might lose entire decades of progress. And for individuals, the trauma of the blackout, the fear of being cut off, would linger like a shadow. The irreversible damage. There are things we cannot bring back. A lost satellite in orbit cannot simply be repaired. It is gone forever. Sensitive instruments that monitor climate, weather, and space may be destroyed. Years of scientific data could vanish. Even more chilling is the loss of trust. Governments that fail to protect their people during the crisis might collapse. Social unrest could spread in nations where the blackout turns hunger into violence. The damage is not just to machines but to human stability. The question that haunts us, and then comes the chilling question. What if it happens again? Solar flares are not rare. They are part of the sun's natural behavior. If a powerful flare arrives tomorrow, could humanity survive back-to-back disasters? Could we rebuild again, or would we finally fall? This question is not fantasy. Scientists remind us that the Carrington event of 1859, an enormous flare, happened long before modern technology. Telegraph wires caught fire. Operators were shocked. If the same event struck today, experts believe it would cripple civilization on a scale we can barely imagine. Preparing for the next one. Some countries are trying to prepare. NASA and ESA monitor the sun constantly. They can detect flares minutes after they erupt, but the warning is short, maybe a few hours before the storm arrives. That time is enough to shut down some systems, but not enough to save everything. The truth is simple. We cannot stop the sun. All we can do is shield ourselves, build stronger systems, and create backup plans. Underground data storage, hardened power grids, satellites with better defenses. But even with preparation, total safety is an illusion. A world humbled after such a flare, humanity would be humbled. For generations we have looked at the sun as a friendly star, warmth, light, energy, life itself. But we would learn that the same star that sustains us can also unmake us. It is both guardian and destroyer. We might finally see ourselves as fragile tenants in a dangerous universe. Maybe that realization would unite us, pushing nations to cooperate on building stronger defenses. Or maybe it would divide us further, as countries compete for survival. Reflection. The dual nature of the sun. In the end, recovery is not just about rebuilding machines. It is about understanding. The sun is not simply our provider. It is also our greatest threat. Every sunrise is both a gift and a warning. So the next time you look up at the sky, remember this truth. The light that warms your face comes from a fire that could one day end everything we know. To understand the sun is to respect it. And to respect it is to prepare, for survival depends not on fear, but on readiness. If you found this journey into the mysteries of our sun thought-provoking, consider leaving a like, sharing your thoughts in the comments, and subscribing for more stories of science, mystery, and the unknown. The sun may rise again tomorrow, but what if it doesn't?